Hello, how are you all doing today? My name is Bernie Thompson, and today we're here to take a look at this little 2009 Chevy Equinox. This little Equinox has a problem where the dash is shutting off, all the dash lights are illuminated apparently, and the door locks start to activate up and down. Now to me that sounds like a bus failure, a bus communication failure. But what I want to see is I want to watch the dash fail. We just got here. So let's get in the car and see what this failure is, what's going on with this failure.
Yeah.
Okay guys, so I've been running the car for almost an hour and it has not done this. So I got tired of waiting and I went in to talk to the shop and they called the customer and the customer has confirmed that this car has to be run for an hour to 2 hours before this problem happens. So it's just like all the problems, you got to run it until it happens before we can see what's going on and we can find this problem. So we're just going to run it until it finally fails. Okay, so the dash is finally failing, guys. Okay, so the dash is failing now. We can watch it fail. And we can hear the door lock cycle as well. So we're having a major bus disruption, I think. I think this is a CAN bus disruption is what's causing this problem. Okay, so let's get a scan tool on this and just scan it real quick. Let's get the scan tool connected. Okay guys, I got the scan tool connected to the vehicle so we can gather the codes, but I'm going to tell you right now, this isn't going to give me the kind of data I need to fix this car with. When I can watch the dash go down and I can hear the door locks lock and unlock, that to me tells me that I have a major failure happening on the CAN bus. Okay, so what's going to happen is every module on this bus is going to set U codes because it's having a major failure. So which one of these codes is really going to direct me to who's causing the problem? Well, I don't think this scan tool is going to help me very much. The way I want to fix this car is to get a scope connected to it and go through and scope the bus, and I'm going to show you how to do this. I do a lot of communication failures in my business. Shops struggle with these comm problems, and I'm a mobile technician, so I get a lot of calls for comm problems. So I want to show you how I'm going to go about this, but I already know that when every module on this bus has communication failures because I have a major bus failure, it's going to be really hard to isolate it with codes. So let's go ahead and get the codes. I want to run an auto scan. Now we already know there's going to be a lot of codes on this car because we've watched the dash cut out with the door locks clicking. So I already know that I'm pretty much wasting my time here, but we're going to at least take a real quick look at this. But whenever you have a major disruption on the bus, like you're losing the dash and the door locks are coming on and off, that's an indicator that you have a major bus disruption. And that's going to set U codes in all these modules. And I don't know how much these codes are going to help me, but we'll get them anyway just to see. Want to make sure we're talking to all the modules as well. Lots of codes in it, that's for sure. And we don't know if they're U codes or not, but we'll find that out here in just a second. Okay, so the engine control module has 9, the tranny has 5, the brake control has 9. So we've got a lot of codes here. Let's go down where we can start to see them. control module communication bus, lost communication with TCM, lost communication with ABS. So this is like what I thought. They're going to all have a lot of communication problems. Lost communication with BCM. And we know if the bus goes down, everybody's going to set codes like this. So guys, this isn't going to be that helpful to me. Okay guys, we can see that there's a lot of COM codes in this bus system. Now, so this isn't going to be super helpful to me on a car where I can watch the dash cut out and the door locks start activating on and off. I just wanted to get them to make sure we're talking to all the modules. We can clearly see that, and we can clearly see that we all have a lot of bus CAN communication errors here. Lots of bus problems. So rather than getting involved here, I want to get a scope on this car, and I want to see what the bus is actually doing, because I'm going to be able to fix the car with a scope much faster than with the scan tool. Let me get that scope connected. Okay guys, so I need to be in the CAN high bus, and I don't want to be at the DLC. I want to be in the bus wires. A lot of time the DLC can have an interface or a gateway where you're not really on the bus. So I always like to get the bus wires. So I find a module that's easy to access. On this vehicle, the easiest module I could access is the ECM. So I've popped the ECM out, and I'm in the CAN high and CAN low wires right here at the ECM. So I know I'm in the high bus right here. A lot of times, depending on the car, you can look at the DLC, but the DLC might not get you on the bus. You might be in an interim, and there's a module or a gateway that could be in between you and the bus. So I like to just come get in the bus so I know I'm in the bus. So that's what I'm doing right here. So now I want to get this car running, and I want to get the data. I want to look at some data from this vehicle. Crank it. Okay, right here is where we got it cranked. There's a lot of noise right there when we started it. Look at all this noise. And look at the bus, how it starts ringing. Now I have noise on my bias or my rest voltage right here, but that's not enough. But this whole frame, that's nothing but noise when we started it there, guys. So I have something going on there. But over here, these are just packets. They're all okay. I have too much noise right here on the bias or the rest voltage, and I'm not at 2.5, I'm at 2.4, but 1/10 of a volt, I'm not chasing that, and I've seen a lot of buses that have noise like this, and I don't have a total disruption on the bus. This isn't what's going on. What I'm looking for is right back here where we started it, and one of the modules started to talk, because when you first start the car, all the modules come on and talk. And we can see right here, look at all the noise that there is there. This is just total noise on this frame. That's a problem. Okay, now I don't see that problem continues. I can see these drops right here in the yellow. But that's not the noise I'm looking for. This bus has some other problem. So I'm going to come over here, and we're going to set the scope up to watch it over here. So the top is on a trigger, and this is on a free run or strip chart roll mode. We can also go to just one screen if we'd like to look at it that way. A lot of times I like when I'm doing this work, I like using two different time bases. Look at that. Do you see it ringing out? That's just total noise. That's total disruption, guys. That's not frames of data. That's total disruption there. It's just ringing. Okay, now that I see that ringing, I want to check the bus resistors. If your resistors go down and I don't have the termination resistors, I'll ring like that. Or a module is bad. The last time I saw one ring out like that, I had a yaw sensor on a Volvo that was sitting in water down in the bottom of the tunnel. Look at that thing ring. That is absolutely, guys, that's your problem. That's not packets of data, that's just noise. The bus just starts ringing right there. That's just ringing, guys. That's just total noise, total disruption. That's why we have all this codes and everything's going on. Okay, so let's check the bus resistors real quick. Okay, so right here, guys, we can see that we've got packets of data going on here. I want to get it to fail, and right when it's failing, I want to shut it off and let the bus go to sleep, and then we're going to check the ohms of the termination resistors. Okay, guys, right there, we've got total disruption. Go ahead and kill it. So now we're going to let the bus go to sleep. That's just total noise right there. That's not packets of frames. That's just noise. But we need the bus to go totally to sleep so we can ohm those termination resistors. Okay. I've got this on trigger, so that's why it stopped like that. Let's go. Okay, so the bus is asleep now. Okay, so this is a bob or a breakout box. And what I'm going to do is I'm going to put this on the DLC. Okay, the bus is asleep, we know. So now I'm going to take my ohm meter and we're going to ohm 6 to 14. And we have 120 ohms on each end of the bus. So your ohms will always be less than the 120. We're looking for 60 ohms. Termination resistors are present right now. That's 60 ohms. I'm expecting about 60 to 62 ohms. So this tells me the termination resistors are in this bus. Always make sure before you ohm it that the bus went to sleep and there's no voltage on here, or you won't get a good reading. Okay, guys, so what do we know? We've watched this car fail multiple times. Every time I get it to fail, I've got to run it for quite some time. The first time, just to start to get the failures, I had to run it an hour. Then if I shut it off, I've got to run it at least another 20 to 30 minutes between every failure. Once it starts failing, it continues to fail until I let it cool down. Okay, so we know that this is a heat-related problem. What generates heat? The engine. So it's got to be some module up here in the engine compartment. Now I don't think it's a PCM because I've got the PCM loose and it's up out of the heat. It's up where I can get to the CAN wires. So what other modules are under the hood that could be affected by the heat? I want to start to look for a module that has something to do with the heat. So let's take a look, guys. Okay, guys, so I've taken apart some of the car so I can get to the brake control module. That brake control module is right down here, and you can see how close it is to that exhaust. Now we know, what I know now is I've got to run this car for about 20 minutes or more to get it hot, and I think that exhaust is radiating heat into that ABS, and the ABS is the one that's creating this problem. So to prove that out, we're going to do two ways. First, I'm going to get it to fail, and then I'm going to cool that module with some substance that will freeze electronics. And if I spray it and the waveform clears out, we know what the problem is. Okay, guys, we're waiting for it to start to fail here so we can freeze the module. Right now we have data communication packets going on. We're waiting for it to start to ring again. Once it rings, we're going to freeze that module with a quick freeze. Okay, there it's ringing out. Right there it's ringing. We're going to freeze it. Okay, that's the freeze we're going to use. Go ahead and spray the module. Okay. Okay, it quit ringing right there. We're back to packets. And it quit ringing because we froze it. Okay, this Tech Spray freezer works great, guys. I've been using it for years. This is a really good way to prove modules. Okay, what does Tech Spray Freeze get me? It gets me the ability to cool the module down instantly. It got hot from the exhaust. I watched it fail. I sprayed it with freeze and it fixed the car. No, I didn't have to unplug any connectors or anything else, because anytime you unplug things, I don't like unplugging things because you're making a variable. When I just cool it down, I didn't unplug anything. I just fixed it because the heat is creating that module to fail, and I took the heat away. I just proved that that module is failing from the heat from the exhaust. That's all I've done. Anytime you unplug things, always be aware you're introducing another variable. Anytime I can prove something out like with freeze, and I can prove it like I just did this car, I feel way better about my diagnosis. Okay guys, when I talk about variables from unplugging modules, if I went down to unplug the electronic brake control module to see if I'd fix my problem, I have a pair of CAN wires coming in from the electronic steering control module, and these wires go to the DLC. That's one pair. I got a second pair that come over and go to the transmission control module and the engine control module. I got another pair of wires, twisted pair right here, that go to the steering angle sensor and to the yaw rate sensor. So if you unplug this module, you're going to probably lose your termination resistors, and then the bus is going to ring. So you can't just unplug a module where we got multiple CAN wires coming in. You're going to have to jump or CAN high to CAN high to CAN high, CAN low to CAN low to CAN low, and then I unplug it, and then all of these are still connected. So now if I'm doing a test, I'm going to jumper these wires. Now I'm going to unplug the module, and now everything will stay up on the bus, and it will work just like this was plugged in, except this module's bad, and I'm trying to take it out. I didn't want to go through all this, so I thought I'm just going to freeze this module and prove it that way, and it worked great for us, didn't it? Okay guys, we're back over at the shop. The shop got the part finally and got it on. It's been over 2 weeks. This brake control module was on factory back order and the shop couldn't find one anywhere. He finally found one and he's got it installed and he's got it programmed, and he's been driving the car for over 2 days. The car is totally fixed. The diagnosis was spot on. Okay guys, wow, is that just a cool diagnostic or what? I love doing comm problems because most of them aren't that complicated. You can get really hard ones, but don't be afraid to get into these communication problems. If you have a good scope, you too will be very successful in doing communication data links just like I'm showing you. I do a lot of comm problems, and I really enjoy these kind of problems. Don't overcomplicate it. Keep it simple, gather the data, follow the data, and you too will be successful in your base.